Welcome. Here are some ideas about parallelism with some different transformations and trying to determine after the transformation if the image is still parallel. And we can use these in our proofs once we've developed these. So the first thing is, what does it mean to be parallel? Note that these little arrows here is a shorthand way to indicate that these two lines are parallel. Their definition is two lines that never intersect. So for example, if we were to continue this line and we were to continue this line and we were to do it infinitely, they would never cross. Two lines in a plane that are everywhere equidistant. So that means that if you look at a line segment that is connecting the point and its image, it's always going to have the same distance. Two lines that have the same slope, let's say this initial one was 1/8, that means that another line with a slope of 1/8 would also be parallel. So that's what we mean, those three different definitions that you can use when you talk about parallel. Now here is an example. You start with a triangle. And go ahead at these 3 points. And then in this case, we're doing a translation to create its image. And then what you can say, see if I can get this to, there we go. So you created its image. We can say, when are the translations parallel? Well, all of these segments are going to be parallel after the translation. And so when this question right here, when are they actually parallel? After a translation, corresponding line segments in image and preimage are always parallel or lie on the same line is another possibility. Like, let's say, for example, that the translation just went to the right. Well, then you can see that this segment right here lies along the same line. So corresponding would be like this is parallel to this is parallel to this, and this is parallel to this. I showed them as being congruent, but it's also true that they're parallel. I could show it like this also. And here. So translation, they're always going to be parallel, or even on the same line. Rotation's another one we could look at. So here is our initial triangle, and this time we're going to rotate it around the origin 180 degrees. So in this case, let's see if I can get that a little better. You can picture each of these points has an image that's 180 degree rotation. This one's another one over here like this. Okay, so what is parallel? When are rotations parallel? What you notice is that this particular segment and this particular segment after the rotation are parallel. So after a rotation of 180 degrees, corresponding line segments are parallel or lie along the same line. And that's after a 180 degree rotation. Okay, you can also see this is parallel as well as this one. So I'm showing the corresponding line segments. And then the final one is, well, what about reflections? So we've got our initial triangle. And then we're going to reflect over the x-axis. So here is our reflection. A little better there. And you can see each point is reflected over the x-axis, is our line of reflection. And the question is, when are reflections parallel? Well, here it's a little different. You can see that this particular base of the triangle is parallel because it is also parallel to the line of reflection. And that's what they're saying here. After reflection, line segments in the pre-image that are parallel to the line of reflection will be parallel to the corresponding. So for example, let me use this. This segment right here, since it's parallel to the line of reflection, the x-axis, it will also be parallel to its image.